My name is Dr Michelle Dickinson. I've learnt that breaking things down is the easiest way to understand them. So join me. We'll break down scientific concepts, meet some amazing scientists and inventors, and help you discover the world around you.
Kia ora, I'm Dr Michelle Dickinson, and today we're going to be talking about astronomy. Astronomy is the study of everything in the universe beyond our Earth's atmosphere. Everything in the universe, every single thing that we know about, is floating in the nothingness we call space. Exploring other worlds can help us to understand our own world, and we've made many amazing discoveries about our universe just by looking up at the stars. Now, space is a big topic, so we won't be able to cover it all today, but by the end of today's episode, we will have learned about the phases of the moon, the planets closest to us, and more about gravity and its role in our solar system. We'll also do an experiment to show why the shape of the moon in the sky appears to change throughout the month. To do the experiment with me, you will need a sheet of paper, a light source like a lamp or a torch, some kitchen foil, and a stick-like object. I have a wooden skewer, but you can also use a stick or a pencil. And of course, don't forget your notebook and pen so you can write down your observations. If you haven't got those things to hand now, go grab them. A bit later in the show, I'll be checking in with one of my science helpers who'll be joining us from home, and speaking to two of my friends who'll be able to tell us even more amazing things about astronomy. If you look up into the rangi or the sky at night and it isn't cloudy, you're going to see lots of points of light, which may be whetu, or stars, maybe planets, or you might even see marama, the moon. The moon will be the largest object that you can see, but that's not because it's the biggest object in the solar system. It's just the closest to Earth. A moon is a small object that orbits around a particular planet. When we say orbit, we mean that the moon is circling around the Earth in a curved path, usually at the same distance away from the Earth. When we say moon, we usually think of our moon, but other planets also have moons, and some planets have more than one. The moon is a great visual reminder that there is so much more out there in the universe. Our moon is about a quarter of the size of the Earth. Even though the moon might be the brightest thing in the night sky, it doesn't actually produce its own light. Instead, it just reflects the light of the sun. So moonlight is actually just reflected sunlight. The moon is always the same size and shape from Earth, and we can only see one side of it. Depending on where it is in its orbit, it can look different due to where the reflected sunlight is hitting it in comparison to what we can see. If the Earth was standing still, the moon would take 27.3 days to make a complete orbit around the Earth. But because the Earth is orbiting around the sun at the same time as the moon is orbiting around the Earth, it actually takes the moon 29.5 days to return to the same spot. This is what we call a lunar month. The shape of the moon we can see from Earth is called its phase. The phase of the moon is defined by how much of the light side of the moon that we can see from where we are on Earth. The full face of the moon will always be lit up, but sometimes we can only see one part of that lit up face. As it's a cycle that goes round and round, there isn't a start or a finish. Let's begin with the new moon, which is the name that we give to the phase where we cannot see any moon in the sky. This happens because the moon is in between the Earth and the sun. So the half that is lit up is facing away from us, which makes the moon look black in the sky. As the moon orbits around, a slightly larger piece of it appears each night. When the moon looks like it's getting bigger, we say that it is waxing. The moon becomes a waxing crescent when there is a slither of it showing. And when half of the face is lit up, we call it the first quarter. You might have also heard this being called the half moon. When the moon looks almost full but not quite round, it's called a waxing gibbous moon. And then, of course, when the moon is full, we can see the whole circle. Then the moon appears to shrink, as we can see less light reflected from the surface. Instead of waxing, we use the word waning, when the moon appears to be getting smaller. So we get a waning gibbous moon, a last quarter moon, then a waning crescent moon, and finally, we end up back at our new moon. Now, let's look at our solar system, which has 8 planets that orbit around the sun. In order from closest to the sun to furthest away, we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Now, when I was at school, I learned that there were 9 planets, and there's an extra one called Pluto. But this has since been reclassified as a dwarf planet rather than as an actual planet, which is why we only have 8. Mercury and Venus, which are the 2 planets closest to the sun, don't have any moons. This is because of gravity. The strength of gravity depends on the size and the mass of the object, so bigger objects have more gravity. Moons are kept close to their planets by that planet's gravity. But Mercury is so small that the strength of the sun's gravity would pull away any potential moon and it would crash into the sun. Venus is large enough to have a moon, but for some reason, it doesn't. Scientists aren't sure why. As we know, Earth has 1 moon, Mars has 2 moons, and all of the rest of the planets in our solar system have various numbers of moons too. The 4 planets that are closest to the sun are called terrestrial planets. They are made up of rocks or metals and have a hard surface and are smaller than the outer planets. The outer 4 planets, Jupiter, Saturn, Uranus, and Neptune, are called the gas planets because they have a smaller solid core but are mostly made up of gases such as hydrogen and helium. The distance between the planets in our solar system differs because they are always in orbit around the sun, and because they are different distances away from the sun, their orbits take different amounts of time. Our Earth orbits around the sun once every 365 days, which is why a year is 365 days long. It takes Mercury, the closest planet to the sun, 88 days to do a full orbit, while Neptune, the furthest planet from the sun, takes 165 years to do a complete orbit. Now we know more about moons and planets, let's do an experiment to show us why the moon looks different in the sky throughout the month. Hi Rakei, how are you?
Kia ora.
We're going to be talking about the moon today. Have you seen the moon before?
Yes, I have.
And does it always look the same?
Sometimes, just has shadows on it sometimes.
Cool, so we're going to learn about why it has shadows on it sometimes by making our own phases of the moon experiments. So we're going to make a moon to get started. So take your scrap of paper and scrunch it into a ball.
Okay.
Perfect. Now you're going to put some foil over the top of it and scrunch it over. So you're going to make a shiny ball.
Done?
Perfect. Now put your skewer in it so you've got a ball on a stick. So this is our moon on a stick. Now what's interesting is when we look at the moon, so if you hold your moon out a little bit, what we can see is the surface of the moon. So that surface that you're looking at is always the same surface. We only ever see the same side of the moon. We never see the back of the moon or the other side of it. So what we're going to do today is imagine that we are the Earth, so your head is going to be the Earth today. You have the moon, and then you're going to need a sun. Do you have anything that could be the sun over there?
I have a lamp.
A lamp is good. So for this, you either need a lamp or a torch or even a phone, but let's turn your lamp on. Okay, my lamp is now on. And so we're going to use your lamp as your sun. Your head is going to be the Earth, and your moon is going to be the moon. So we're going to start with the sun over there, the Earth in the middle, and the moon over here. If you stretch your moon out, Rakei, so it is opposite your sun and your head is in the middle, you should be able to see it looks like a full moon. meaning that your moon is a full lit circle. Can you see it?
I can see that.
Now we're going to rotate a little bit. I'm going to come this way, and you'll start to see a shadow on this side where the sunlight can't hit the moon. And so this is either called a waxing gibbous or a waning gibbous, depending on whether the quarter moon is going towards a full moon or away from a full moon. Now we're going to keep going around, and you'll start to see a quarter moon here. So the shadow is on half of the part that you can see of the moon. And keep rotating around, keep going, keep going, keep going, until your moon looks totally dark to you. And that is because the half of the moon that we can't see is fully lit, meaning the half of the moon that faces the Earth is not lit at all. And we call this a new moon. And so as it keeps rotating, it's going to go around until you go back to your full moon. This is how original calendars were made, as people were able to tell the time using the moon. How was that, Rakei? Did you see them?
Oh, that's actually kind of cool, yeah.
When you look up at the sky and you take a look at the moon, you can see the shape and you can determine whether or not you are seeing a full moon, a new moon, or something in between. Thank you for helping me today, Rakei. See you next time.
Bye.
Okay, after any experiment, we need to write down our observations. These help us to understand our results and make interesting predictions for our next experiments. So, observations. What did we see? Well, the lit up shape I could see changed when I moved the ball, or my moon, around my head. So when the ball was in between me and the light, I couldn't see any of the ball being lit up. But when the ball moved all the way around and my head was in between the light and the ball, I could see the whole of the lit up shape. It was a circle, like a full moon. I could see different shapes lit up at different points in the experiment. Now, when we look at our observations, we can reflect on them. By asking questions about why something happened or how we might make it happen again, we're really starting to understand the science behind it. For example, in reality, the relative sizes of the sun and the moon and the Earth are different. So what would this experiment look like if it was actually to scale? Also, the moon isn't normally so shiny like foil. So what material could you make your moon out of to make the light reflection more realistic? Okay, now we have a little bit more understanding about stars, planets and moons. Let's talk to an actual astronomer. Dr Ian Griffin is an astronomer and director of Otago Museum in Dunedin. Having spent the first part of his career discovering asteroids, he is now dedicated to sharing his passion with others through his stargazing and aurora-chasing experiences. Hi Ian, how are you?
Morena, Michelle, I'm very well, thank you.
Thank you so much for joining me today. Let's start with your childhood. When did you fall in love with astronomy?
I saw an eclipse of the moon, which is something amazing, when the full moon turns a red colour. And I saw it when I was about 4 or 5 years old, and I became absolutely fascinated by looking at the sky.
So let's talk about that. So you talked about telescopes. Now, when we think of astronomy, we think telescopes. Is there any other equipment that you might have used?
Well, actually, you don't really need a telescope to do astronomy at all. All you need are your eyes to go out at night, and you can see some amazing things, even if you don't have binoculars or a telescope. So, for example, if you go out this time of year, if you get up early in the morning, you can see the planet Venus before the sun. And that's a really bright object in the morning sky. And you can see that with your eyes. You don't need a telescope. One of the exciting things about astronomy is there's always something new to see in the sky, whether it's the changing phases of the moon or a new comet or perhaps something else. So there's always a lot to do and a lot to find out about the sky.
And have you discovered anything in your lifetime as an astronomer?
Yeah, believe it or not, when I was studying at university, I was very interested in things called asteroids. These are little tiny rocks that move around the solar system, mostly between the orbits of Mars and Jupiter. Now, I set up a program to study the asteroids, and as a result of that, I actually discovered, I think it's about 26 asteroids now that I've found. And one of the cool things about finding an asteroid is you get to propose names for these things to something called the International Astronomical Union. So asteroid number 10924, for example, is called Maria Griffin. That's my wife. And my children, Hope and Merope and Angus, have all got asteroids named after them as well. And these are all official. You can Google them. And it's quite a fun part of being an astronomer, is you do sometimes get to name things in the sky.
And so what is the best thing about astronomy? Obviously, naming asteroids is pretty cool. What do you love about it?
Oh, here in New Zealand, we're so blessed because, for me, astronomy is all about going out and looking at the beauty of the night sky. And I know it's cold in winter and people tend to kind of wrap up warm, but this time of year, if you go out and you stay up really late, about midnight, the Milky Way is high overhead in the sky. And if you get, and in New Zealand you can do this, you can get away from the city lights. If you go to a really dark place and you just lie on a blanket and look right up, you can see this gorgeous, lovely, glowing clouds of dust and gas high above you in the sky. And that's the center of our galaxy. And for me, the joy of astronomy is all about looking at those things and realizing that that light has been traveling for thousands of years in some cases from stars that are a long, long way away. And every single point of light in the sky is a star like our sun. And around those stars, there might be planets. And around some of those planets might even have life. So astronomy really gives you a sense of scale. We're here on planet Earth. And when you look up at the night sky, you can see that there might be thousands of other planets like ours. And there might be people like us on those planets looking at the sky, thinking and wondering if there's life elsewhere in the universe.
And you mentioned before about aurora. Tell me a little bit about that.
Yes, one of the lovely things about living in Dunedin, I know it's pretty cold down here, but in the south of the South Island of New Zealand, very occasionally we get to see a wonderful glow in the southern sky. And that's called the aurora australis, or the southern lights, or actually Kaitahu call it na kahukura o hini nui te po, or the rainbow of the goddess of death. Now, auroras are stunning, and a good auroral display, you'll see this lovely green and purple colour and dancing lights in the southern sky. And auroras are caused by material from the sun, which zooms across the solar system and interacts with our atmosphere and makes it glow.
Ian, thank you for your time. Can you give me one amazing fact about astronomy that you wished everybody knew?
Yeah, I think the most amazing thing about astronomy is it tells us where we come from, because most of the atoms in my body were actually made inside a star billions of years ago. And I think that's astonishing.
That is astonishing. Ian, thank you so much for your time today.
Great speaking to you, Michelle.
When we think of astronomy, we often think about scientists learning about the universe by looking at stars and planets. Even before the invention of telescopes, celestial objects have been teaching us about the universe and how to find our way as our ancestors used objects in the sky as well as on the Earth to help them navigate. Let's learn more about this. Dr Haki Tuaupiki is a researcher at the University of Waikato, using traditional navigation knowledge and contemporary voyaging practices to help a new generation of Māori voyagers to reconnect with their tupuna and with Polynesian navigators across the Pacific. Tēnā koe, Haki, how are you?
Pai ana, I'm good, thank you.
So can you introduce yourself to everybody at home, please?
Kia ora everyone, my name is Dr Haki Tuaupiki and I work at the University of Waikato as a senior lecturer and a researcher. E mihi atu nei kia koutou e whakarongo mai nei ki e nei kōrero. E tangi ana te ngākau ki te tupuna heke nuku mai pūhipi, kia Papa Mau Piailuk, kia Clay Perlman hoki, kai arahi o tēnei mātauranga I te wā I a rātou, ka mihi hoki kia Hoturoa, Barclay Kurt, rāua ko Jacko Thatcher. Tēnā koutou.
Kia ora, thank you for that. So tell me a little bit, we've got so many tamariki watching this at home, tell me about your childhood and whether or not you always knew you would be in science.
Well, without knowing it at the time, I was actually learning science from a very young age, learning ancestral knowledge about the ocean, around the ocean, and Māori plant and tree knowledge. concerning medicinal use, that was very common in my household when I grew up.
So you lived close to the moana, near the ocean, and that's had a big impact on what actually you do now in your research. Can you tell us about your research?
Wow, that's a big question. My research is mainly around the regeneration and revival of traditional aspects of Māori voyaging and navigation knowledge. Polynesian ancestors were great navigators and sailors. The sky was their internet, and the ocean superhighways and motorways comprising of voyaging passages and networks which connected them to other peoples from around the Pacific.
So today in our episode, we have learned about the phases of the moon and maramataka. And so how does that relate to how people used to navigate? Did they use the moon?
There's a number of elements that our ancestors used when navigating. They would use stars. They would use the sun in particular and the moon. And then if the sky was covered, they would rely on other elements which included the wind, and tidal currents and swell.
Haki, can you sum up your research in just one sentence?
E kore ngaro he takere waka nui. We will never be lost. We descend from the hull of a great canoe. And that's a proverb, and it talks about retaining knowledge and the importance of ancestral knowledge and the importance of carrying that forward into the new world, and how there is relevance with the ancestral knowledge in today's society.
And so today, as the sun goes down, if we all lie outside and look up at the stars, is it true that what we look at is actually the same thing that our ancestors would have navigated through, and actually it's a way to connect us all through the generations?
Good question. Yes, the stars above are the same stars. Unless a black hole has eaten some of the stars that aren't there anymore. But those stars represent the highways and the motorways and the GPS system that our ancestors were able to utilize and travel from point A to point B and return.
I love it. Okay, thank you so much for your time today. It's been fascinating to go through what is basically a time travel history about how astronomy has been used by so many people for so many years. Ka kite anō. Thank you.
Kia ora. Thanks, Michelle.
One thing that I've always wanted to know about space is whether or not there could be aliens. Well, the scientists who work on understanding extraterrestrial life in the universe are called astrobiologists. And that, I think, would be an awesome job. Astrobiologists use technology like infrared light and space probes to study the conditions on other planets. 10 years ago, NASA started the SOFIA mission, a powerful telescope mounted onto the top of a Boeing 747, which could let us look at other planets without having to look through so much of our own atmosphere. SOFIA made many amazing discoveries, including one which is relevant to how we understand the beginnings of life. SOFIA observed that some carbon-based molecules changed when hit by radiation from nearby stars. This is interesting because life on Earth is also based on organic carbon. Instead of destroying the molecules, the cosmic radiation actually helped them to grow. While this is not yet what we think of as life, this does tell us that, under the right conditions, the growth of organic carbon-based molecules in space could be one of the steps that leads to alien life. A bit closer to home, scientists studying Mars think that millions of years ago, Mars had a climate that could have supported life. Since then, Mars has cooled down so much that nowadays the surface is partly covered by ice and the temperature can drop to minus 150 degrees Celsius. Not exactly comfortable temperatures. The next challenge for astrobiologists, now that we think life could have survived on ancient Mars, is to look for any signatures that it might have left behind. By that, I don't mean Martian palaces and space cities. It will probably look more like signs of bacteria or other microorganisms in caves and subterranean oceans. The search for biosignatures of life on Mars is ongoing and could yield some fascinating discoveries in our lifetime. There's still so much to learn about space and much more to discover. With advances in technology, we are able to see and travel further than ever before. As we do, we will learn more about our universe and whether or not we are the only planet to have life on it. The more we explore, the more questions we have, and that's why being a scientist is so great. It's like a never-ending journey of discovery. Teachers and parents, don't forget to visit nanogirlslab.com, where we have downloadable content to help you continue on your science journey into space exploration. Thanks for watching. Is light speed travel possible? How long until humans can visit Mars? Which planet has the most moons? Are there aliens out there? Why isn't Pluto a planet anymore? How come the sun keeps on exploding and just doesn't go out like a candle flame? If gravity pulled the moon into orbit, why doesn't the moon keep getting closer to Earth?